Hi, I'd like to talk about a real-world example of applying some of the advanced laws from trigonometry, and that's trying to land a plane with a little bit of a crosswind. Now, runways at airports, when they're numbered, are numbered based off the first two digits that the digital compass in the aircraft would read. So if you were trying to land on runway 01, your plane would need to be flying at an angle of 10 degrees east of north. And landing on runway 19 would put you at an angle of 190 degrees east of north. Well, say that there happens to be a 10 meter per second wind that's blowing 50 degrees south of west, and your plane is flying through the air at an unknown angle that we need to determine, but it's flying through the air at a forward speed of 70 meters per second. So what would your angle need to be so that your plane would be tracking directly along and parallel to this runway, even though you would be facing slightly away from that runway? Well, taking a look at the vectors involved, we're essentially doing a vector sum of the forward velocity vector of the plane through the wind and the sum of the motion of the wind itself. So the wind, here I've redrawn it as just 40 degrees west of south, and here's my unknown angle east of north at 70 degrees. Now this isn't to scale because technically it should be 1/7 the size of this first vector, but if I take my wind, shift it up to the beginning, the velocity of the plane through the wind plus the velocity of the wind relative to the ground gives us the velocity of the plane relative to the ground. Now, we could go about breaking both of those two vectors into parts, summing the parts together, and then recombining those parts into one vector using the Pythagorean theorem and using the inverse tangent function from the components we get. But we have enough information to make use of either the law of sines or the law of cosines. Well, taking a look, I'm going to call the velocity of the plane through the air side A of my triangle. I'm going to call the velocity of the wind side B, and I'm going to say that the result, which we don't know, is side C. Well, my angle opposite A is called alpha, my angle opposite B is called beta, my angle opposite C is called gamma. Well, we don't know that angle, gamma. Our angle beta would have to be equal to our unknown angle that we're looking for minus 10 degrees, because we have to be flying a little bit east of the runway in order to line up so that the plane would track straight towards the runway on approach. Now, the last thing we would need then is to figure out what our angle alpha is, and then we would have an angle, a side, and a side, and angle side side means we can use the law of sines. So, taking a look at the vectors that we know, well, if I were to take my two vectors and kind of redraw them over top of each other, this unknown vector I know has to be at an angle of 10 degrees from north. My wind has to be at an angle of 140 degrees west of north. So that means I would have to go 10 to get to north, another 140 degrees to get to the direction of the wind, so that angle between the direction of the runway and the direction of the wind is 150 degrees, and because my angle alpha is opposite the intersection of the line that the wind is traveling on compared to the line that the runway is on, that angle alpha also has to be 150 degrees. So again, the law of sines is what is guiding us here. So the sine of alpha, which we know alpha, divided by side A is equal to the sine of beta, which we don't know, but we want to find, divided by the length of side B, which we do know. So solving for beta, the sine of beta is going to be B over A times the sine of alpha, and beta would be the inverse sine of that quantity. So B is 10 meters per second, A is 70 meters per second, so that gives me 1/7 times the sine of 150 degrees, and the sine of 150 degrees is 1/2. So 1/7 times 1/2 gives me the argument for my inverse sine. It's less than 1, so we're going to get an answer. And the inverse sine of that value, 1/14, is 4.1 degrees. So that means that the plane has to be flying an additional 4.1 degrees east of the runway, and 10 degrees plus 4.1 degrees means the plane would be traveling with a heading relative to the magnetic north of 14.1 degrees in order to be flying relative to the ground at an angle of 10 degrees. Thanks for watching.